welcome. Thanks for coming. So at this session, you're not going to learn about optimization or troubleshooting techniques for Postgres. It's going to be more a story from the application development standpoint. So that's the time for you to cool down from all of those advanced tech sessions on the Postgres internals and different tips and tricks. But anyway, I believe it's going to be interesting, especially for those of you who are application developers or those who are collaborating with their application developers on a regular basis. And the features that we are going to look into today, they are not futuristic. It's not like it might be good to have something in Postgres. It's basically the features that are already represented in several databases. They are used widely by application developers, but they are not in Postgres yet. So, a little bit about myself. I've been working with distributed databases and high-performance computing systems for the last 8 years. So presently, I'm with Yugabyte, and before that, I was contributing to Apache Ignite, another distributed database for in-memory computing daily. And prior to the databases, I've been on the Java development team. I was developing JVM and JDK at Oracle and Sun Microsystems. So today, to look into these features, I call for help from two application developers. So please welcome Julie Jess. She is an experienced front-end developer who knows Node.js, creates different full-stack applications, and kind of in this industry for at least 10 years. And we have Java Joe, a principal architect and engineer who have been creating apps with Java for almost 2 decades. When they started coding, because like the first feature that we are going to touch on is related to developer experience. And when it comes to developer experience, it's important to understand how developers create and write code these days, how they deploy the applications and how they interact with the databases. So Java Joe, he started, let's say, in 2000, somewhere in that time. He still remembers the time when he had to install Postgres, configure it on that machine, and whenever he needs to go to his colleague, a DBA, and ask to provision Postgres and configure in the staging environment. But Julie Jess, she's a little bit different. She started in the time when Amazon Aurora was already the thing. And for her, a database is more like a connection endpoint because she can go to cloud, provision an instance of Postgres or any other database and get this connection endpoint. And that's primarily the whole interaction. So that's the experience of today is like, I go, I click several buttons, and I get this connection endpoint. When it comes to the coding, so the screenshot probably is not of the best scale, but more how those application developers see a database on their daily basis when they write code. Java Joe uses Spring Data. Spring Data, the first version, it's like a ORM framework and was released in 2003, a long time ago. And for them, when you create code, you operate on Java objects. Like for you, a table is just some object class with different fields. And you interact, you call different functions and methods through different Java names. So if they write SQL code, we do write SQL code. Java Joe does this, but he doesn't do this frequently. Most of the time, for him, the database is Spring Data. Everything is abstracted. In the JavaScript community, and JavaScript is becoming one of the top languages, and I think it overturned Java in terms of the popularity this or next year. Prisma, that's another ORM that is very popular in the JavaScript community. It was released in 2016. It's not that a little bit after the announcement of Amazon Aurora. And again, for Julie Jess, the database is also a collection of different entities in JavaScript in different classes. So this is how they see the database. So the experience, what I'm just trying to highlight, the experience right now that the developers have, they understand what a database is for, but most of them just getting a connection endpoint for this database, and then they're using ORMs. They just write code in their programming language to get data, to write data from the database. Which means that in many of those technologies, like take Prisma, Spring Data, they do a lot by investing in the developer experience. So like different, minor and small steps help the developer productivity. And this is why the first feature that we're going to discuss is, the name is a little bit lengthy. We are going to talk about compute tasks like experience for application developers. So let's figure out what a compute task is. So let's say you have an application code. The application code is compiled. Like the CPU executes it, and finally it gets to the point such as like do this function. And that do this function gets executed in your database. So, and then if this function needs to return anything to your application process, it will do. If it doesn't need to return, it will return nothing. And next, what if to give you several examples? Is there anybody who booked a hotel or a flight in Expedia these days? Yeah, like at least, yeah, I do. So Expedia actually uses, whenever you want to get a flight from point A to point B, Expedia runs compute tasks on the database side. They basically execute Java tasks, and those Java tasks pull different information. Sometimes they need to call APIs of different airline companies. And then these kind of compute tasks are executed for, let's say, thousands and thousands of users who go to Expedia daily, right? And Judy.js also worked on another team. She was creating UI interface for JPMorgan Chase. So JPMorgan Chase has a lot of fintech products. And she was working with backend developers, and those backend developers used compute tasks to decide how to manage portfolio, because you know that right now probably the market is quite predictable. The market goes down, but when there are bright days, the market like fluctuates, goes ups and downs. And there are many people who put money in JP Morgan's accounts, and they provide portfolio management service that helps to decide, all right now, one stock goes down, what should I do with this portfolio? I need to analyze the current market data, the previous market data. And again, compute tasks, the tasks that get executed on the database nodes over their existing data help to create services of this kind. And they are created in the language of the application developers. So why Julie and why Joe selected compute tasks, right? There are primarily two reasons. The first one is you want to execute data-intensive logic in the database. It's like the JP Morgan use case when you have historical data, probably big data or like current data, and you want to decide what to do with the portfolio of several customers. Or you have compute-intensive logic. It's when you have a multi-step operation. Your application, before application completes a business operation, it needs to split it into multiple steps, read, write. And this is the use case of Expedia when you want to see the flights from point A to point B. But primarily, why do we need those compute tasks? We want to have them to bring network utilization to the minimum, because network, like even when you run in the cloud on your own data centers, the latency sometimes is extremely low, but it depends on an application. If you have, let's say, like thousands of users a minute, then the network impact will become noticeable. And right now you can just look at me and say like, but it sounds like familiar, right? Like, does it remind you of any feature in Postgres? Stored procedures. And the question is, why those developers do not use stored procedures? Why they use some sort of compute tasks that are extremely familiar, that extremely remind me of stored procedures? There are actually three reasons, right? The first reason is SQL is not their mother tongue. Remember the first two slides, how developers see a database. For them, a database is ORM, whether we like it or not. They do write SQL, but they don't write SQL daily. Most of the time, they write JavaScript or Java code. Then the ownership, because stored procedures are sub-programs. You want to get some sub-program and you want to execute it on the database end. And sometimes there are some, clashes and, conflicts between developers and DBAs, because you want to deploy some logic, it will take time, I need to have an approval process, blah, blah, blah. And third one is some of their logic that you want to execute, your logic that you created, it uses third-party libraries. For instance, JP Morgan uses third-party libraries created like for risk analysis created by other vendors. And those libraries are not written in, they are written, let's say, in Java, and they need to use Java. But another fair statement that you can tell me, and I will support it, but come on, what are you talking about? Number one, SQL is not the mother tongue. This problem is solved in Postgres. We do have PL Java. So like that Java Joe developer, just go ahead and tell him, just go ahead and use PL Java if you want to write in your lovely Java language. It's available. And Java Joe, he is a reasonable guy. Remember I told you, he is in the industry for almost 2 decades. Like he's an architect, principal engineer. And he took and tested PL Java. So, and that process split into multiple steps. First, you need to do what? You need to compile. You need to compile this extension. You need to install this extension on your database. Then you need to enable this extension on your database. And finally, this installation process is over. You are ready to build your code. You will build your code. Then once your application logic is ready, you need to deploy it. Once you want to update it for any purposes, you got a bug, you have some performance optimization, so you're just in early development, you need to recompile, you need to redeploy. So the first process, let's look at the feedback of Java Joe. And again, Java Joe is sort of spoiled by the modern development technologies, ORMs, etc. Indeed, he managed to compile and install everything in Postgres. He managed to install this extension, but it took time. It takes time. It can take, let's say, 20 minutes, 1 hour or more. It actually depends on your operating system, on your machine. If you are not lucky enough like me, who runs on Apple M1 processor, it will take more time for you. If you're running on Ubuntu, on, let's say, Intel chips, then it's going to be faster. But that's like a minor thing. You usually do this once and then you forget about it, right? A little bit more complicated thing that is related to the developer experience is this one. The extension is ready, and right now I want to write my logic, for instance, for Expedia. I'm creating this function that needs to do something, and right now the function is ready, I want to run it. All right, I need to connect to Postgres, I need to install it, I need to compile it, and I need to repeat this every time whenever I need to introduce the change. So this is not a big deal when you are in production, because in production, we are all reasonable. We have some processes, right? Change process whenever you want to update your production. But in development, that's a problem. Let's see what I mean, and then you will be able to compare to other solutions that solve this from the developer experience standpoint. So what I have, I'm on my Ubuntu machine. And on this Ubuntu machine, let's try to run this simple logic. So what I have, this application, simple function. So the function actually says, Postgres, say hi. You run this function on your Postgres, and the function will collect information about your system, like what's operating system you're running on, and different information about the Java and the memory that is available and given to your Java process. So the first step, what you need to do, as we know, you need to compile this function. I created it right now, I need to compile it. So let me go to this project, Java database functions, and as a Java developer, clean package. I'm creating the jar file. All right, the jar file is ready. So now let me connect to my Postgres instance that is running on that machine. And so now I am ready to install the extension. So the jar file. The jar file is compiled. It's available on this local system. So we don't need this. We need this. What we need to do is to provide a full path in this case, which is in my home directory. It's installed, wonderful. So now I need to add it to the public schema so that it's visible for my requests. And finally, I can query this function. So the function executed successfully. I can see that that's my environment, Linux, AMD64, and that's my Java version. So far, so good, right? But the process, what I need to do as a developer, and remember, as a developer, I just need to repeat this for every change. What I go right now, let's say that I found some optimization, but I don't want to optimize. There is nothing to optimize in this function. That just to show you their experience. When I need to change anything, like, hey, I've changed this logic. I've changed this logic. So right now, as long as my database server is running on a separate machine, which is quite standard situation, especially with your staging environment, I want to test it. I somehow need to deliver that package, I don't know, to that machine. Let me go to this project. I am doing this git pull. I am getting these changes from the repository. I'm assembling this package once again. Once it's ready, I'm connecting to Postgres. And now I'm ready to actually redeploy. Let me copy the command. It's going to be, I know, it's going to be faster this way. I need to execute replace function. And the function replaces the previously deployed thing. And right now, when I execute, why it was not updated? That's interesting. I said execute. So let me see Maven. Let's try once again. Git pull. It's up to date. We do Maven clean package. And now, let's go back to the SQL. Let's redeploy it. And if I execute, say hi, strange. Anyway, it works. Probably there is something missing in my case, but the point here is just not to show the capabilities. You certainly can write Java logic, but to show you their developable experience. It's just cumbersome when you do this over and over again, especially in the early development cycles. So like, how is it different? Like if it's available in Postgres this way, like what can we say about other databases? In Oracle, actually, Java Joe went ahead and checked Oracle. So in Oracle, when it comes to the installation, especially to the database as a service, because I can go and deploy Oracle in the infrastructure, you don't need to install anything. You basically go and enable this extension for Java just in one instruction. But then, when it comes to the development, right, when I want to write the real code, the process is not different from PL Java in PostgreSQL. I need to create the logic. I need to somehow connect to Oracle database. I need to bring Java artifacts there, and then I need to redeploy. And I do this and do this over and over again. Snowflake, which is becoming a buzz right now, Snowflake actually came up with two different flavors. When it comes to the production deployment, we always have some processes. And in the production, you basically will follow the same process as you would have with PL Java with Oracle. But when you're in early development, Snowflake allows you to create this wrapper, like create that function. And inside of that wrapper, you can put your Java code. And then Snowflake will take and compile and run everything for you. It's not the most ideal use case, but at least you don't need to do this operation. You don't need to copy all the time. At least you can debug and you can finish your function this way. With Apache Ignite, this is the developer experience is, I would say, the ultimate, because you as a developer, again, same as with previous example, you write your logic, and then when you want to run this logic in your cluster, you just click the start button. Similarly, as let's say with your database as a service, when a developer wants a database as a service, you provide a configuration, you click start, you get that instance. When you want to run your function in Java or JavaScript, you compile your application, you click start, and the function automatically gets transferred and executed over your cluster. So let's see how it's compared, because you still remember how many steps did it take for me to execute this logic in Postgres with PL Java, and let's compare this to Apache Ignite, which is one of the examples. So in Apache Ignite, let me start it on my local machine. use this method. So where am I? Yep, I'm in Apache Ignite. I'm starting a single node cluster. It's just one instance, one process running on my machine. And the function is identical to what I have with Postgres. It's basically the same function that says hi, and I'm collecting information from my local operating system and from about Java, JVM, etc. So the only difference is that when you run this Java logic through Ignite, you're using a special API endpoint. It's called compute tasks. And then this is what I'm doing. So let's say that I want to run this. I run this Java class, just the click of the button. So the application is running, and that function is executed on my database node. So the logic got transferred, serialized for me, and it executed on my cluster node. What if I want to change this logic, which is a regular situation in development? All right, it's easy. Let's go and do this. Hey, let's do the same. I've changed this logic. What I do, that's the application. I need to stop this application. I'm not touching my database. I'm not connecting to this database directly. And what I do, I just restart my application that was updated with this logic. The new version of the application is running. I'm going to the database and I'm seeing this. So like basically, this is the developer experience for the compute tasks that you might add to relational databases, right? So this is what developers want. Developers, like we always talk about that developer productivity and blah, blah, blah. And right now, when you live in this world when, let's say, every database instance can be available within sometimes seconds, if not minutes, and you have ORMs, this is actually what helps to expedite the development and usage of store procedures like use cases, because it's really important to create stored procedures, but the way how you create, deploy, and update those stored procedures is a little bit more complicated. So, returning to the So probably with Postgres, right, what can be done? Because from the feature standpoint, PL Java is a wonderful extension. It's pretty powerful, it exists. But it's always, about, let's say, the final steps that can make application developers to say that, now like this is something that is really wonderful and this is really useful for me. At least, probably with Postgres, we can start with something like what was supported by Snowflake. Even if I open a PSQL connection, and even if you let me just to add my logic in there inside of this wrapper, and then the PL Java can compile this logic for me, it's already a big win, especially in the development cycles. And then, if it's needed, you can always see like how it's done in Apache Ignite and other products who are focused on the compute tasks. How the things are going with Julie.js, with the JavaScript community. JavaScript is a little bit different language, and with JavaScript, the situation is a little bit easier for the developers. You also can create your custom function in JavaScript, but you don't need to compile your JavaScript logic and deploy it to the server and redeploy it in the way you do this with Java. Similarly, as with Snowflake, you can put your JavaScript logic inside of this function and get it executed straight from your PSQL connection, which is at least one of the improvements for you as a developer. And probably like what can be done for the JavaScript community, because it's easier, just if, let's say, you have this Postgres application, that JavaScript application that is connected to Postgres, and you come across this function that is basically a stored procedure written in JavaScript, just get it executed, transfer to Postgres instance automatically, and get it executed there. It's all about, let's say, the protocol level communication changes, some of the ideas, because it's all about network. You can take this JavaScript code, you can serialize it, you can send it over the wire, deserialize, and get it executed. Because PLv8 extension is powerful enough. It uses their engine that is used by Google Chrome browser and many other frameworks. And actually, Oracle database is heading in that direction. If you use Oracle Autonomous Database and if you use one of the Apex products, you can really take your JavaScript code and get it executed over the database, just copy paste, and Oracle kind of run it automatically on the database for you. So that was the first one, feature related to the developer experience. Talking about their second one, distributed storage and query layer. So this feature, it's not like something that developers use directly in the code. It's used implicitly. It's used as part of your application solution and your application infrastructure. So let's imagine that Java Joe and Julie.js, who worked together at JP Morgan on that project for the portfolio management, eventually they decided to found a startup company. This frequently happens. When two colleagues, one company decided, let's say, to quit their well-paid job and found a company. And they decided to found a startup company. And that company creates, some fintech service. And they have to execute fast enough. And they deployed the first version of their application. And after the first announcement, they've got Mrs. Blue, a financial advisor from New York. She became one of the first users among other hundreds and thousands in the United States. And the application was running normally for almost a month, but then we had a natural disaster in the region. When the application was running, the whole region was impacted, the database was down, the application was down. That was not a big deal for them at the current stage of the startup company, but they took the lesson. They did the research and figured out that, in fact, that cloud infrastructure does fail. It's because many of us moved to the cloud, and especially this move accelerated with the pandemic. And cloud comes with abundant resources, but also it's a very complicated environment. The more dependencies you have, the higher the likelihood that something will fail, either infrastructure or services, etc. And AWS does a great job by writing and sharing all of the post-mortem summaries of different major incidents. And major incident, it's not like a zone-level incident that happens on a regular basis. A major incident is when a whole region like US West or US East can go down and all of the services and applications are not available in that region. And we are not blaming AWS. Actually, AWS thanks a lot to this company because these post-mortems is a good educational resource for those application developers and architects who are in the cloud but do not take high availability seriously. And even before this talk, I decided just to do a quick Google search, just Google for cloud outage, and I was impressed to see that within, let's say, several days in a row, there were different outages in many companies, like from airlines to AWS alone, they were impacted, they were not available. Which means, and that's okay, that's fine that cloud fails, but the question is like, are you ready for those failures? And they kind of figured, right, we are ready right now, and as long as they're focused on the United States market with the first version of the application, they run multiple instances of the application in the database. Okay? So what else, right? And then, let's say another incident happened, another region went down, but their application was running because all of the users were able to query and write data to other instances of the application. What else? What else they discovered? Because and this is a kind of a long introduction to this distributed storage and compute feature, but it makes sense, let's say, to understand like the way of thinking of application developers. So that was high availability. It's important. But sometimes, especially with startups, and when you start, kick off a new project in your organization, you can kind of start thinking about high availability later when you get some sensible customer base. But there are another reasons when you start looking into distributed solutions. Let's welcome two new users who joined this application. We have Mr. Green, a scientist from Berlin, and we have Mr. Red, a musician from Mumbai. And right now, imagine that Java Joe and Julie.js decided to ask them about the application user experience. What do they think about the application? Mrs. Blue, who uses this fintech application on a daily basis, she says, wow, it's lightning fast. I usually open this up on my mobile phone. I check, let's say, the status. I can buy stocks. I can trade stocks. Because for her, the average latency time for the request from her mobile phone to my application instance and database is around 5 milliseconds. She lives in the region that is the region of my application database deployment. For Mr. Green, his feedback might be, overall the application is good, I like it, but sometimes it stuck. So sometimes I refresh it, I'm just trying to click, and it takes, let's say, several seconds before I see the change. And here is, again, for him, it's not a surprise, because he lives in Berlin, and his request needs to travel through the land and under the ocean before they get to the United States. The latency adds up. But Mr. Red can be furious. He might say, why these guys recommended me this application? I can barely use it. It's always, slow. It's always blah, blah, blah. Because, it's, again, the latency through the land, under the ocean, and the latency adds up. The speed, right, of how your application and database responds to the request matters a lot. But right now, we have another thing that many application developers and architects are bothered about, which is the data locality. Because sometimes, whether we like it or not, you might end up getting users in different jurisdictions. For instance, Java joined Julie.js during the first year of their application. Their primary focus is on the United States market. But people like their service, it's get recommended, and they're getting, the first users in Europe and Asia. In Europe, everyone knows about GDPR. Right? GDPR is the thing, like everyone gives this as an example. The thing is that right now, if Mr. Green buys anything through this app, all this his personal information is going to be in the United States. That's a problem. Probably it's not the problem for this application at the current state because they are not officially in Europe and they don't have a big customer base. But in the future, if they consider Europe, they need to do something about that. In India, actually, let's take India as another example. In India, the Reserve Bank of India put and ordered the law that requires you to store the payment information of the Indian residents in India and not in other country, which means that in this application service created by Joe and Julie, they sell something, right? They close transactions. You can use compute, you can run those transactions in the United States, but effectively within several hours, like 24 hours, all the payment information has to be moved to India. So this is the requirement. And generally, just if to give a high level, the highest level possible architecture, it's like the first thing you need to deploy if you want to solve these problems, high availability, low latency for the users around different regions, and data locality, you basically don't have that many options. You need to figure out how to deploy your application across multiple regions, and you need to deploy the database. With the application, it's all clear. You just go and deploy, provision your instances. With the databases, there is no any silver bullet solution. It depends. It depends on your requirements, and we're not going to discuss it today. But generally, this is the solution. How exactly it's going to be implemented, it's up to them. So if to recap why Joe and Julie selected a distributed storage or a distributed database, it's like this quite a cliche, scale out compute and storage on demand whenever you want to scale horizontally. But then what most important is you want to withstand various cloud outages because then in the cloud you want to deliver low latency for reads and writes across different locations, and you want to comply with data regulatory requirements. The question is, does this feature belong to Postgres or not? Because to the core Postgres. And this is a good question because distributed storage and query layer is a significant improvement. And we know, like we heard from Bruce Mamjam, that there is some, development in progress and there are different products. Or probably it needs to be separate. For instance, Yuga by DB and Neon are forks of Postgres that provide, let's say, that solve this problem differently for different use cases, but that might be another way, right? And different companies come up with different solutions for that. If to speak for Yuga by DB, at least my point is that probably with core Postgres, there is no reason to rush. You just need to take your time and decide if you truly want to make the Postgres distributed, a distributed database, but at least there should be a way for Postgres developers to migrate to a distributed database the seamless way possible. And this is why, for instance, I highlight Neon, Yuga by DB, or Amazon Aurora, right? Because those are built on Postgres, and you can, with a little effort, not the little, it depends, you can migrate, let's say, with the little over architecting of your application. Speaking about Yuga by DB, if to take a single node, right, and dissect it, it's built on the PostgreSQL source code. It's basically Postgres, what you have. But underneath, its distributed storage layer is inspired by Google Spanner. If you've heard about Google Spanner, that's a distributed database that is available only in the Google Cloud. But generally, this is how it works. It supports Raft consensus, automatic sharding, load balancing, and transactions. Those who are interested in what's their compatibility level, and that's a broad discussion. So generally, if to take it this way, everything you see here in blue is Postgres, and in Yuga by DB, planner, executor, and optimizer were enhanced and modified so that those components of the Postgres engine can execute queries effectively over the distributed storage of Yuga by DB. So this is what was done. So let's take a quick example, because, all right, so right now we use Postgres, right? And when the time comes for you to think about high availability or, like, let's say, low latency in different geographies or data residency requirements, but you are with Postgres, so, like, what are your options? Let's say that, let me run another demo. The demo is as follows. Let's look at this first version of the application that Julie, Joe, and Julie and Joe created. I have it here. We call it market orders application. So now let me, and I have, the first version runs in Google Cloud. I have Google SQL. It's basically managed PostgreSQL by Google. Nothing new. So that, just paying to Google for the management. And then I am starting this first version of the application. So the application connects to the database, and then it connects to the stream of different traits. It captures traits and puts them in your Google database in PostgreSQL. So this is what we're getting right now. And let's imagine that for some reason, for one of those reasons that we discussed, Julie and Joe decided to migrate to a distributed database. And they considered Yuga by DB. They are looking into the Yuga by DB. So what are the options? First, you can always stop. You can do a snapshot. You can move data. They provisioned a Yuga by DB cluster. So right now, they're planning to run in a single region. Okay. So it's going to be in a single region, but across multiple availability zones, so that at least they can withstand zone-level outages. And next, let's do the migration. For instance, they want to migrate data from Postgres in Google Cloud to Yuga by DB cluster also in the Google Cloud. So the first command, they are migrating the schema, exporting the schema and data from Google SQL. Data export started, not that much data. And second, they need to import all this data into their distributed database. We are creating schema, different types, domain sequences, tables, and then eventually foreign keys, materialized views, whatever is used by this first version of their application. And now we are ready for the data. So their schema is replicated, applied, imported, and we are moving the data. So all the tables are imported. And the next step, they are ready to run this application. So they are using the same, no changes in the application. The only change is on their, let me run this. I am going to the market orders app. Only change is your connection endpoint. You need to connect to a different database. So we are connecting to Yuga by DB, the same application, no any code changes. And we are getting new stocks. We already have some data. The data was imported from Google SQL. And now, why they did this, I mean, again, high availability, and also, in addition to the high availability, they are balancing reads and writes. Because this is a sharded, this is a distributed database, and every node is keeps a subset of the global data. So that's why whenever you read or write data, one of the nodes will be handling this for you. So this is the second feature. And the third one, I had several features in mind, and then I was looking deeply in Postgres and realized that Postgres, some of the features are already implemented in Postgres, but the developer experience can be improved. And I didn't want to talk again about developer experience because we reviewed another feature for the sake of developer experience. And then I thought, all right, as for the last feature, let's talk about high performance computing, because that feature is built upon the previous two. When you need to have a distributed storage, when you need to have a distributed compute layer, and plus you have that compute tasks-like experience when you can execute your stored procedures in a way the compute task can be executed. So if to, again, return to our heroes, let's say the Java Joy and Julie.js right now run their distributed database cluster, they're highly available and blah, blah, blah. And right now they need to improve their application because basically they want to introduce some portfolio management capabilities. They need to do some risk analysis, meaning that analyzing data, current data and old data, and they want to run this compute logic. They did this in the past. So if to remind ourselves like what a compute task is, effectively it's the same as stored procedure, but it can be executed straight from your code. It's like you have your application, you have this do this method, and this method is executed on your database, and that's it. With the high-performance computing assumes that you have multiple nodes that can do this execution of your logic. And if you have this distributed database, then when your application comes to this point, like do this function can be executed on all of the nodes. And then you can use this compute power, or you can just do this the way you like. Or also what high performance computing allows you. Let's say that you can decide, you can pick a node where your compute task can be executed. For instance, let's say that my application is used by Mrs. Blue, who is in New York, and she is using this new portfolio management feature. And right now the market fluctuates in my service that's created by Julie and Joe. It needs to decide like, all right, I see that in Mrs. Blue's portfolio, there are several stocks that are going down right now. What do we do with them? And they can run a special compute logic on the node that stores transactions and primary information about the portfolio of Mrs. Blue. And her ID is 5. So this is how your application service can say, all right, run this task and logic on this node, like where this is located. And this is how you can load balance requests based on the data locality of your customers. All right, so let's do this. I'm not going to show this example generally. There are also several databases that support it, including Apache Ignite. It's not supported in YugaByDB, so YugaByDB is still more like Postgres. So it supports stored procedures, and the experience with stored procedures is similar to Postgres. But probably at least we will have a few minutes for the questions. If you want to learn more when it comes to these capabilities and to the architecting of these solutions, applications for the cloud, I'm usually advising these books that are wonderful from their application developers and architects, data-intensive applications and architecting for scale. If you want to learn more about YugaByDB, there's the resource. If you have any questions to me about, let's say, this all sort of type of related solutions, so YugaByDB, you can find me on Twitter. But we have 5 minutes left, so any questions, any suggestions, any remarks, please welcome.
So isn't this a variant of what was done in Hadoop, like push down, map, reduce, distribute to all the nodes that have the data and then collect back?
That's right. It reminds of the last one, right? Feature like that. It's the Hadoop style map reduce paradigm. There are several variations of it. You can like Spark. Spark actually. Spark implemented a little bit different approach. They have data frames and RDDs, but the idea is the same, right? In your logic, take Python or Java, you write your logic, and then it's going to be executed over your like push-down approach, or it can be executed in Spark workers that cache your data. So the idea is similar, more of a MapReduce. It's quite close from the feature perspective, but let's say there are some little things that make this experience different. And when you talk about this, like compute tasks or stored procedures, there is still like the developer experience related thing.
Well, I have a question. I may be a little out of date here, but doesn't the PL Java, is there overhead in running the JVM separate from the database? Because like with PL v8 or like Python, it runs like, isn't it the same process set?
With JS and Python, it's simpler because you don't need to compile your Python or JS application beforehand. You basically can feed your source code into their, let's say, PL v8 extension for JS, and then the engine that is used by that extension, V8 extension, that V8 engine created by Google and used by Google Chrome, it basically will take your code, it will compile it, it will run it, and then it will optimize it. So it's simple, let's say, from the architecture standpoint. With Java, yes, you always have to run Java virtual machine. When I was testing, when I was running this with Postgres, I didn't notice any, let's say, at least I was not doing load testing, right? But let's say from this standpoint, it was always seamless. I see that the Java runtime is running. The extension definitely doesn't start a JVM, like stop JVM upon the invocation of my methods, which is good. Oracle actually has more control on this, and for instance, for the Oracle database, their Java runtime environment is very well integrated into the database. For instance, when Java does garbage collection, when you run Java functions in Oracle, the garbage collection happens at the session level. For instance, let's say you use some application that connects to Oracle, and you kind of use this application, you generate garbage in the JVM on the Oracle database side, and your garbage will be garbage collected separately from mine. So this is how the garbage collector is integrated in Oracle. And also the scheduling, because Java is a multi-threaded, which means that all of those sessions, all of those connections to Oracle that are open, they are mapped to the scheduling or the Oracle database. It's like the Oracle database decides like which thread is going to be executed, which thread is going to be put on pause. So this is what Oracle did. Also, Oracle has GraalVM, which is their new virtual machine that allows you to compile your Java code into the binary format and run this Java code, let's say, as a C application. But they actually, what's interesting, they don't use this for Java. They use this GraalVM for their JavaScript and Python extension. Like the JavaScript support that is available in Oracle Autonomous Database works on top of the GraalVM JVM, because that GraalVM JVM can execute JavaScript or Python, etc. This is what they do. But generally, this is what's happening. Oracle does this. Oracle still improve this direction. But that's a long answer. The short answer again, I didn't notice any, let's say, performance drawbacks when I was using PL Java, at least for my quick tests. So it's good. I mean, like the extension is good. Like it's feature completed, I think. The point is like right now, what's the easiest way for me to use it as a developer? Probably I can always create, some scripts that will automate this deployment, but it always would be nicer if there is something out of the box that basically just that, the one button click process.
Cool. Okay, well, that's all the questions. Thank you very much.
Thanks.